Okay, welcome back. So I've just got started on this and I'm going to talk you through it. We're doing the 2023 DEB paper 2 question 1. So we have a standard deck of cards, and as we read carefully, we read the 2 cards are drawn at random from the pack and not replaced. So after drawing one, and when you're drawing the second one, the deck is down by 1 card. Find as a fraction the probability that the first card drawn is a diamond. Okay, well, you have a full deck there. There are 13 diamonds, so 13 events. So the probability of a diamond is the number of diamonds, which is 13, over the number of outcomes, which is 52. And this reduces to 1 over 4. Okay, now, what's the probability that both cards drawn are diamonds? Well, the probability that the first card drawn as a diamond remains 13 over 52. Just bringing it back to its original form. And then once that diamond has been removed, I've indicated a single diamond being removed, but it doesn't have to be that one. There are 12 left, and there are 51 possible outcomes. So when you have probabilities, one after the other, so the probability of this being a diamond and the second one being a diamond, whenever you have the word and between events, you're using multiplication. And you multiply them out and you get 1 over 17. Now we're going to read this very carefully because I misinterpreted it at first. That's the reason why I've had to restart the video. So we're going to read very carefully. Find the probability that the 2 cards drawn from the pack are in consecutive order. Now, what we're interpreting this of is, and it could be debated, but that once you've drawn a card, the consecutive card is 1 up. It's called a successor. You cannot go 1 down, in other words. And it wraps around. So ace has a successor of 2. 2 has a successor of 3, etc. So what it means is you can start anywhere. So the probability of drawing a card is 1. And then once you've drawn that card, and you could think of it as, okay, I drew a 4 of clubs, then there's only 4 fives, 4 consecutive cards for that, above that, which is 4, and there's 51 in total. So 4 over 51 is the answer here. Done. Well, I better say that because I've written this as a product, which is equal to 4 over 51. On we go. 2 cards are drawn at random from the pack of cards and not replaced. Find, correct to 4 decimal places, the probability that neither card drawn is a king. Okay. Now, thinking about this directly is quite complicated, but thinking of it as being 1 minus kings being drawn. So now for kings to be drawn, you either drew king, king, you drew not king, king, this is how you say not king, or you drew king, not king. Now these are 3 mutually exclusive events. So what I'm going to do is I'm going to find the probability of this, and then I'm going to use the fact that the probability of something not happening is 1 minus the probability of it happening. So the probability of not an event, which is written like this. Okay, it seems very complicated at the beginning, but this is saying the probability that the event doesn't happen is equal to 1 minus the probability that the event does happen. Okay. So we're going to work out at these 3 things now. And the thing about these things, these are all have ORs in them, or, and when you have ORs in probability, you're adding. So what seems at the beginning to be the most complicated thing is to know when do you multiply and when do you add. Okay, so these are mutually exclusive. If you thought of this as a tree, these are the kind of things that end up being out here at the end of a tree diagram. Okay, so let's go through them. What's the probability of drawing a king and a king? Well, the probability of drawing a king is 1 over 4, and the probability of drawing the second king is 3. No, it's not 1 over 4, it's 1 over 13. Sorry about that. Okay, let's just use the pure big numbers. Probably, how many kings are there in the deck? 13. So you, no, there isn't. There's four kings in the deck. I'm getting into a right mess here. 4 over 52. Now, how many kings are left? 3. And remember, we're continuing on with the not replace, I hope. Not replaced. So 3 over 51. But we're also going to look at the probability of not drawing a king. So now there are, I'll tell you, the easiest way to say not drawing a king is literally 12 over 13. Reduce it down. Otherwise I'm talking about 48 over something. Okay, so the probability of not drawing a king, and then the probability of drawing a king is, now I didn't draw a king, so there's 13 kings left, but there's only 51 cards left. This is complicated, isn't it? Okay, let's get started on the calculator and get this calculation dialed in. 1 minus, even though I don't have to, I'm going to put it in brackets so I can add these instead of subtract. So 1 minus the probability of king, king. Now king, king, as I said, is, how many kings are there? 4. How many cards were there when you drew that first king? 52. Multiplied by second king. How many kings are left? 3. How many cards were left? 51, because the king was gone. We drive on from that, move out from under the fraction bar and add a plus. And we're going, what's the probability of not king, king? Okay, I have to do some careful thinking here. What's the probability of not getting a king? We can come over here and this can help us. What's the probability of not getting a king? Well, if we go with absolute numbers here and don't reduce it, we have, and this is a completely different experiment, so we've reset the deck here. So we have not king, this 48. Over 52. And on to the second part of this. Might be easier to come out. Let's see. I want to come out from under where, what do I do? Is it this arrow? And multiply. It just might be easier to kind of keep track of what I'm up to compared to this bit, the way I did that one. So, okay, let's go back here. How many kings are there on the deck? I haven't drawn a king. I've drawn a non-king. So there's 4 kings in the deck. And how many cards were in the deck at this stage? There was 51. Now this is kind of going to happen again in reverse. Okay, but so I'm still going in here with a plus, and I'm just going to write this again now. Or I could put it 2 times this, or I could turn that into an 8, and it would be correct as well. But just in order for you to kind of get a sense of what's going on, this time I'm drawing a king. So what are the chances of a king? How many kings are there? 4 over. Again, this is a whole new thing. This didn't happen if this happens. 52 times you drew a king. How many non-kings are left? Drew a king. How many non-kings are left? Not king. 48, right? You didn't draw it. It's 48, I'm still there. 48 over 51. Come out, finish your bracket, and hit equals, or shift equals for decimal. Most important thing is it's below 1, and neither card drawn is a king, and we'll just go with that. Equals, actually, I'll just check this, the marking scheme. I have it open here. Full disclosure, I'm looking at the marking scheme on the right hand side, and bring it over here do not say they want to correct to 4 decimal places. And they're not even, is it 1 minus the product? And they haven't corrected it. Neither card runs a king. Or else they're going to go on to correct like at least one. Just haven't given a decimal here, have they? They're giving it this way. 48. So I'd have to calculate that because they've never done so. Probability neither card drawn is a king, but they've done. That's not enough. Which was 1 minus the probability of all of these. Which was pointed, and did it go to the right number of decimal places? To 4 decimal places. I should have said to 4 decimal places. Let's come back to that. 0.8507. I'm annoyed with them really because they didn't that mark, and that's why I say maybe we should stay away from DEBs because they don't always get it right with their marking schemes. Now, having said that, their decimal values down here might well turn out to be 0.85. Yeah, they have 188 over 221, but they say that hasn't been reduced. Let's look at it. 0.8506. Clear. Just take their answer. They're even saying this isn't a reduced answer, but they're giving it as a possibility. There it is. So the marking scheme is very, very complicated for something that's simpler. Now you could certainly say though this again is a higher order question and quite challenging. And I look at how long it's taken me to do it. Okay, we drive on. At least one card drawn is a king. So let's come back here to thinking about this carefully. At least one card drawn is a king. Well, that's this. And that's the opposite to this. Okay, so we will just subtract 1, even though that's wrong ways round in sign, and shift equals that. Now I better be careful because would it do that again now? I want that in decimal. I think I better be better off not doing shift equals because I think if I do shift equals it'll recalculate. I have to be very careful. So I'll format that to decimal, which is 0.14932. And to 4 decimal places it's like this, and they have 33 over 221, but they're not even being careful about turning it into decimal. Let's see, is this right according to what they've got? 33 over 221. Clear your decks. 33 over 221. But they asked it for digital decimal, so I don't see why they're not giving it in decimal. At 149. Okay, so these are called complementary. As always, students, now it took me a while because, you know, to think my way through it after not doing probability for a while. That's typical. But it's all about the thinking and the processing, and that's what you saw me doing there, problem solving and reasoning. As always,